Good morning, Howard.
Hey, good morning.
How are you doing? Did you have a
With as,
good skiing
with
visit?
as many people that are on this meeting, I'm surprised at 2 minutes of we don't have more showing up early, but maybe not.
They tend to all arrive around 8 or 5 minutes late, so that
Yeah,
tends to be the
um,
sort of trend.
maybe just human nature. I don't know.
Yeah, I understood you were skiing last time, a few weeks back when one of your colleagues joined a couple of times.
I don't think I went skiing this year.
Oh, right. Well, you were somewhere then.
I was in Boston. I ran the marathon
Oh, it was a marathon. That
a
was
couple
right.
of weeks
Oh, well,
ago,
similar to skiing, using your legs.
and yeah, yeah, but as it turns out, quite a bit slower. Um,
Congratulations.
thank
Uh,
you. And last week, um, my extended family has we're all car guys,
uh,
and my dad had a very old Bentley, like
oh,
Mr. Steeds, depending
mhm.
upon the age, know who that is. And um, so my dad has passed away, and that got moved on to my cousin Mark, who has more money than all of my brothers and I do. And so he bought that from my dad and did a wonderful job in restoring it and keeping its old nature. And I met him out in Western Pennsylvania, and we took it out on a long drive as part of the Vintage Bentley Drivers Club of some kind. And there were more of these Bentleys than I've ever seen in my whole life at
Really?
incredibly fancy resort. And each day they had a 100-mile loop off to different places. We went to Falling Water, the Frank Lloyd Wright House out in Western Pennsylvania.
Mhm.
And we went to the Flight 93 Memorial one day. And so I missed a few days in the middle of the week last week, but I had a wonderful time with my cousin and getting a ride in my dad's old car that he had had for many years and sat in the barn at home on the farm. And so, and seeing these incredible Bentleys driving all over, some of them with steam pouring out at the tops of the hills, and some of them that lost one thing or another on the way. And they had trucks with parts and well supported, and somebody needed a new magneto for these cars built in the 1920s. And they had one on the truck and they fixed the car and sent it on its way. But
Nice.
yeah, it was, and we spent the whole time watching the temperature gauge as we climbed up the hills. Sometimes we stopped at the top and let the heat remain. We after the first day, we carried several gallons of water with us and antifreeze. So, but in the end, it was quite a shakedown cruise for the Bentley, who had recently only been rebuilt. He did a wonderful job and spent buckets of money on the car. And
Nice.
the other people that were there, you could tell that they were, these were not just regular everyday people. These were Bentley types. So, yeah.
Nice. Nice. That sounds great. I was at a chili cook-off where they were showing off some classic cars, but nothing quite as elaborate as that.
And how are things in Lisbon?
It was good. It was a good show, and I mean, it's a lovely city, and my brother lives out there, and I've got
Oh,
a friend out there, so I made a vacation of it as well.
that's wonderful. That's lucky to get a chance to do that. And before everybody gets on here, given the political environment here in the United States, my wife and I are looking at moving to Europe. Where my daughter lives in Sweden, and so we're going to.
Yeah, there's
I
a lot of Americans who moved to Portugal. There's some good deals
Yes,
for tax-free moving out there like a few years back. I think it's tightened up a bit now.
my I have friends from high school that live there, and I see them. We're coming up on my high school reunion here soon, and so I'm seeing more and more people. But they live in Portugal, and they've done well for themselves. and financially. And so I often see them. Here we are on the what's the name of the trail that goes through Spain? Hiking the begins with C. Looks like it's hundreds of miles. I forget where it is. Castian Trail or something. Anyway, they're pictures from the beautiful ocean, and oh my gosh, they're doing fine. So they probably won't be back for the high school reunion,
Nice.
but we get to see on a regular basis. They're just picture taking types, so that we get to see them all over the world. Really good. But you're right. Spain and Portugal are getting their share of Americans that have had enough of
Nice, and
the.
it's super cheap and they're super friendly there.
Yeah.
So one thing I didn't do, which I've just done, is I normally send out a quick note the day before just to say, yeah, the meeting is going ahead or not. So I did literally just send one out there just to remind people, but maybe, hopefully it's
It
not.
went out. There was an automatic one that went out.
Yeah, there's always an automatic one, but I normally add on a little one just to
And
say,
I think that makes a big difference because
yeah,
oh, there's Mitch.
okay.
Because that little personal thing, because he says, yeah, that's tomorrow, delete, right?
Yeah, yeah.
But when you say, here's our agenda,
Yeah, you
well,
get
then
them.
you have a reason to go. So I think that's important. There's Jason.
Maybe
Hey,
these,
Jason.
Hi, how are you? Hey.
Hey.
you guys.
So having that little personal thing, even if it's just a one-liner that says we're going to talk about one thing or another, makes a big difference for people to show up.
Yeah. Yeah, so maybe Jason and Mitch came because I just sent that note out.
Jason,
Yeah. Hi, how
where are
are you?
you? Are you still in
Good.
California, Jason?
Yeah.
Okay. So are you permanently in California?
Yeah.
Okay.
All right. Well, we are 5 past the hour. So I'll tuck in. Just checking a few things there. All right. So really all I had today was well, a couple of fairly significant things. I obviously gave the presentation update at the Lisbon OCP Regional Summit. Great summit, as I was just saying to Howard, and that included, my presentation included a little section on the Universal Interconnect. I think we have gone through before, but I did do some finalizations on that. So I can quickly just go through that particular part of the presentation just to bring everyone up to speed. And the other bit of news that I think I sent an email out on was that I pinged Oak Ridge National Labs on the New Frontiers RFP, and they replied saying that it's back off hold, they are working on it, and we should expect to see the final RFP late in June. And assuming they're on the same timeline as they've told us before, after that, then that will be 4 to 6 weeks that we have to get in. So I guess we should be shooting for the end of July to have a wonderfully polished proposal to at least give ourselves half a chance of maybe getting some funding for some of these ideas. So that's really what I wanted to cover. Just with regards to the OCP Regional Summit presentation, I really put it as a task on myself, as much as anything with these different work streams, was to put a bit more meat on the bone, so to speak, of all these little sub projects that we've got going on. And I was going to make the effort to then put that into the RFP, so I can outline the scope in a bit more detail as to from a high level perspective as to why we're doing each of these different things. And then obviously from specifically on the interconnect side, where turning this into reality, I think would be where we need some more detail in the proposal as to what would be done. from the interconnect players that wish to participate. On that particular note as well, I'm not sure if we've got the time, but it might not be a bad idea for us to at least start to get one of these formal specifications in place to describe the interconnect in a bit more detail. And if we can make some progress to put a little bit more detail behind my cartoon concepts, that we believe, this is an achievable interconnect. So, because obviously what I'd like to get to in the proposal is that we get to a POC, ideally a POC for everything, the entire module, that we can actually have a module built with all of the aspects being folded into that module design. And on the universal interconnect, obviously having some prototype universal interconnect cables manufactured that we can actually prove that has the potential to work. So I don't know how far we can get in the next, where are we, beginning of May. So we've technically got 3 months, or just shy of 3 months to get this together. So maybe we can get an outline technical specification of the universal interconnect in place, and that we can add to the proposal material. And that might be a good...
Alan, I'm going to ask you a question here.
Yeah.
So, because I think this is very close to Jason and my heart here, in that, do we have, like we have for PCIe, say, Gen 6, signal integrity requirements, sort of blocking or tying the product that would come about, or bringing the MCIO type of, or MCIX product to have a required signal integrity for, 3-inch, 6-inch, meter long, however you want to measure it, cable assemblies. So certainly it makes sense to tie in to existing requirements, and then to broaden out for specialty requirements. So I think where we stand now, and Jason, speak up if I don't fear to interrupt me here, because I'm sort of wandering around in my head here.
Yeah, because I think the current is just define the module area, and for the application is not sure. So I think it's difficult to define the cable whatever length. But follow the PCIe, that's we call the internal cable assembly. Because assembly there is a spec layer, and definitely that spec is based on some PCIe, that's a budget in the channel budget things. Okay, so at this moment, I think the current just define the module itself. Okay, I think the module on the wall, that area only, not define the plug-in module, the spec, right? So the all application layer. So I think it's kind of tough at this moment, because the application is not clear defined there. Because this one will accept the lots of different kind of application there. So this one, right? So it's difficult to narrow down, specific spec.
Well, okay, yeah, so you're absolutely right. Especially with the word universal, it's like, how do you be all things to all men? It's pretty challenging. So actually, I think that's maybe a good segue, because I think I have a view on that I did try to articulate. And I think the regional summit presentation, let me just flash up the regional summit presentation slides here, and then we can start working from that.
Yeah.
But yeah. Go on.
before I ask a question, because this one will accept the PCIe and also Ethernet, whatever, any kind of the module.
Exactly.
Before
Yeah.
I ask about the reference impedance, then that's
Exactly. Yeah. No, that is a very good point. So okay, so good thing to discuss, and it'd be good for us to use my slides to discuss around it, because so if I share my desktop, number one, share, ignore the Tesla Dojo a minute. Let's by the way, that's something else, by the way. This is a Tesla Dojo tile. I'm looking at, if we put 4 or probably more like 9 modules together, we can actually maybe host this new tile approach that TSMC and Tesla have done in Cerebrus. Have done, but obviously the Tesla TSMC one means you can do heterogeneous. So I'm planning to say, hey, our wall of compute could also support this this new sort of effort in terms of wafer scale modules by ganging our modules together. So that's something that I'm just exploring at the moment to show that we can be a little bit more future-proof. But anyway, changing the subject there. Here you go. Let me just pop this presentation on. So can you see this Universal Topology Interconnect?
yeah.
Okay, so this is the first slide of the Regional Summit presentation. So none of this will be new, but it's a pretty good thing for us to talk around the points that you've just made. So obviously we're talking about the topology interconnect, which is the top and the bottom here, these 8 connectors. I've said that the current plan of record that we seem to be aligning to is, hey, let's leverage the PCI SIG MCIO connector is our starting point. No point in reinventing the wheel. You know, that's obviously in a high volume today, and it's supported by PCI SIG. So we know it's going to be good for PCIe just to start with. But we do want to be, to both your points, protocol agnostic across any of these standards. And importantly, from a speed perspective, we want to go all the way from like the PCI Gen 5 all the way up to the Ethernet 224. Now, my point here is, well, actually, let me just finish the generic. So I then said we want to upgrade the sidebands from the 1970s technology that we still have on the likes of PCIe to more of this, and I'm targeting this as at least as a starter for 10, is this tunneling over the LVDS tunneling protocol that OCP has adopted. And it looks like that's making some good inroads. I think even ASpeed are putting LTPI natively into their processors now, which is good to hear. And clocks, and we only have one static pin for telling us that we've got a cable is present in the connector. And then we've got these active cable options, so we need to bring power in the region of less than 10 watts. And so that's where we have the active components, and I've showed an active PCIe retimer. This is the standard footprint, PCI SIG footprint for a by 8 retimer that you get Broadcom and Astera Labs making. So this is the actual real chip size. So that's in paddle card form. And I've said to cool that without being a huge cage of some sorts, we've got the conductive cooling going on here to the manifold, the water-cooled manifold. So that's how we're going to conductively cool that. And maybe we can use the TE thermal bridge on here or another approach. And then I just also showed the Avicenna light bundle with a hole in the paddle card where you would mount and flip over that. I think that would be the ideal if we can do that, if that's possible. And flip that over. We have the ferrule alignment going on inside there to align the passively attached fiber cables to it. And again, we can cool this Avicenna chip again in the same fashion with the connection to the manifold, the thermal bridge. The point here is, and obviously the point I emphasize is we want to support copper, passive copper, all the way the co-packaged optics is the and everything in between. So passive copper, active optical, near packaged optical cables, and then co-packaged optics with passive optical cables. And so that's what we want to do. That's what we mean by universal. Now, so when I look at this interconnect, I mean, if you look at it, it doesn't look, this is obviously PCIe only, and we've got it. I think there's a roadmap to PCIe Gen 6. I don't know if there's a roadmap to PCIe Gen 7 with MCIO. But if we look at Ethernet, we've got this 224 now. But the interconnect setups are fairly similar with some subtle differences. And so maybe we can go passive copper all the way up to 224. Maybe we run out at 112 or the 128 PCI SIG Gen 7. But that doesn't necessarily mean we're not universal. It's just, okay, if you're going at this higher speed, you probably need an active retimer in there somewhere to drive the cable directly. So passive may have its limits in that sense. And this is where the signal integrity, and I think obviously this, to your point, Howard, on signal integrity, obviously PCI SIG is extremely well defined with all the margins, etc. Ethernet is well defined in the QSFP cages, etc. And I don't know, if there's any impacts on how this physical design can support the Ethernet specs. We obviously know this one can support the PCI ones because it does. But so that's where the question comes in, I guess, is, in fact, on the conference, I said, look, this is our plan of record at the moment. So as we do this design, if you guys say, hey, this is never going to work, to leverage some of the features of a QSFP connector, we need to do some fundamental changes to this connector design, then maybe we end up with a custom one. Right. So, at the moment, we had a debate early on in the interconnect meeting. We had a debate where I showed a Samtec Accelerate and a Molex near stack where they don't have paddle cards. They solder the twin axis straight onto the pins, and you get cleaner signal integrity. So you can, so I was saying, is there a way we can support this direct wire attach and also support a paddle card where we can put active components? And long story short, it looks like Samtec probably wouldn't want to open up their Accelerate to the rest of the world. And I think NearStack is opened up already. I think they've licensed it to a few people. But I'm not sure how well that would support paddle cards. So during that discussion, the interconnect people there, which I think were TE, Samtec, and at least one other interconnect company, they all agreed that the paddle card was a viable way forward. So anyway, that was why we sort of ended up saying, well, okay, let's go with PCI SIG MCIO, as it is already in volume production, and we don't want to reinvent the wheel unnecessarily. So does that answer your question at all, Howard? I mean, I'm not saying we've got all the answers, but if we run out of steam signal integrity wise, we just say, well, okay, 112 above 112 gig, guys, you've got to go to active cables to get it to work. And then obviously at the slower speeds, you might say 32 gig, we can do 3 meters or 4 meters or 5 meters, but at 64, we can only do 2 or 3 meters. So there may be a few other things in terms of cable lengths or gauge of cable. On the gauge of cable side, by the way, I am favoring 34 gauge. It's the smallest that anyone does. And I think any bigger it's still a fat bundle of cables, even at 34 gauge. And if we have to go to things like 26 gauge, then I think that makes a lot of our wiring pretty untenable because we've got so much cable.
34 gauge, yeah, that's maybe the loss. Yeah, and so the limited distance, okay, but the longer distance, that's the issue. So that depends on, and the other way, I think the current MCIO is at this moment is good for the PCIe Gen 6 and not sure they can reach and Ethernet 224 gigabit per second.
Right.
But the other way, from your viewpoint, this one just current the placement holder here. Later on, when we experience the issue for signal integrity, either change to the active or either we can consider the different kind of the connector, right? It's not necessary MCL. Is that correct?
Well, the only thing is I think we've got this one opportunity to say we want to cover this scope that we're trying to say here, right? And we can nail down specifics like, hey guys, it's got to be 34 gauge cable because you know the bundle is going to be fat anyway, and we can't go any fatter than 34 gauge. So if that limits us to a meter or less or half a meter, so be it, unless you go active. And we can start to put those things into the spec. If we think that we've got some fundamental limits that restrict our ability, and we want to make, and maybe we can get over them in the future. Like I don't know, you have a better dielectric material, or you redesign the copper pin. It's still fundamentally the same connector, but just the materials used in the tolerances just become tighter, the way you manufacture it or something like that, so you can support the specs better. Things can evolve over time, but we could restrain the scope to say, hey, at a certain speed, the cable length is only this long with 34 gauge twin axe. And so we just make it into an achievable spec, and then we go active beyond that. And if one of the connector companies can say, we can do an extra twice the distance with passive 34 gauge because our twin axe is better, our interconnect design is better, well, great. If somebody can exceed the spec, fantastic, and still exceed the spec requirements and still have the signal integrity, hit the signal integrity limits, then superb. Does that make sense?
Yeah, I think now is this one is kind of the starting point, but later on when the application move up, and then we may create the revision, right? On top of it.
Yeah, absolutely. I mean, at the end of the day, it would be nice if we come up with a scope here, and we can, with innovation within the scope of this, so we can go, we can make progress. Or if at some point we need a refresh where we do need to change the connector design a little bit, then that can be a decision later on down the line. But I just wanted to give it enough legs here that it was universal to cover a pretty wide scope. And like I said, if we need to even do active, if active only works on this at 112 gigs, okay, then so be it. I mean, ideally, I'd like to have a passive copper solution for 112, and I don't see any reason personally why we couldn't get at least some distance with passive 112. In my head, I felt that we should be able to do around 2 meters. One of the other things we got to understand as well, by the way, guys, is when we think of passive in today's world, we've got several challenging things going on in today's world. Like, you have 18 inches a lot of the time between a processor chip and a QSFP cage. And then you have a copper cable, a passive cable from the cage to cage, and then 18 inches again. Whereas these connectors are going to be literally 2 inches or 3 inches away from their driver chip. And so we can give more budget. You poor connector guys are always the last one in the loop to be brought into the equation. And the big silicon guys say, well, you guys have got half a dB loss for your bloody connector. And I think we can be more generous for you with this because we've shrunk everything down. And the other thing is, with 2 meters of cable, we can span roughly 80 modules, 80. Whereas with if you had 2 meters, including the 18 inches of PCB traces inside a 19-inch rack to get to the QSFP cage, you can barely go anywhere. Maybe you can connect 8 modules together at most, not 80. And so if we had to restrict to 1 meter of cable, we could still cover a good span of 40 modules or something like that. So I think our dynamics, and by the way, I worked for Molex, and so I got deep into the signal integrity and the IEEE rule book, which I think is also a little bit broken, but it forced you into these sort of test domains. And I saw the mess of the signal integrity of the OAM module. And so I think I think there is also an opportunity for us to redefine the budget. And we can start with saying the connector guys get a bit more budget. and we have that conversation.
Whenever there's more budget, then it trickles down to someone else. Then
no, exactly. And my point is you've always been at the bottom, and I think that really you need to be at the top.
Well, we've always been at the far end of the wire too. So
right. And by the way, but as a systems guy, when I look at what the others, by the way, in the OAM module, they give 8 dB for the OAM module and including the connector. They need 8 dB. And I said, why do you need 8 dB? I only needed 2 to get from the chip to the connector. And they said, well, inside the package, they give the silicon guys 5 dB to get from the die to the package ball. And then I spoke to companies, they should remain nameless, but 2 very, very big companies, should we say, they compete aggressively against each other. One needed 5 dB to get out of the package, and the other needed 2 dB to get out of the package. So one was shit at it, and the other was great at it. But what did we do? Because the silicon boys are in control, they said, well, let's give ourselves 5 dB. And they only really needed 2 if they were competent. And so I think that's...
Yeah, in the past time, they always squeeze the interconnect area.
Exactly. And again, they take all the budget and they just say, that's all you got left, guys. And it's just not on when you think about it from a system perspective. You need to be a bit more negotiable between everybody at the front end. And I think that's our opportunity here, by the way. And I'll be the first to slap the silicon guys across the face when they say they want most of the budget for their stuff, because they don't need it. And by the way, if we go to chiplets on the substrate, if this becomes a substrate, this module, then we can actually put the chiplet directly above the connector. So we could be less than half a dB between the silicon and the connector, and through the connector to the paddle card. So we could give you 3 or 4 dB of loss in the connector. So this is why I think I reckon we can probably, when I see the demos at the supercomputer, at the shows that you guys do, when you show a demo like 224 gig working over actually quite a lashed up 5 meters of cable, you think, bloody hell, that's pretty damned impressive. I know that doesn't make it into manufacture, into volume production, but you're demonstrating it. It makes me realize that we can probably, I'd like to think that between us, we could do 224 over 2 meters of 34 gauge passive cable. If we had chiplets on the backside of these connectors, meaning that you're literally, the silicon was right next to your interconnect.
Yeah,
now I know,
right, depends on the budget.
Well, yeah, obviously, assuming you still have the 30 dB budget, obviously, thereabouts or whatever. But that's the other thing, by the way, is in my mind, I'd like to reduce the budgets down. And then we use retimers that are, instead of giving everybody 30 dB when you don't need it, we actually maybe start with 2 dB. And you have to have an active cable, but the active cable is then just designed to drive the cable directly from the paddle card and only an inch or 2 to the transceiver chip. So you can make decisions as to how far you want to drive and how much energy you're going to burn. Because why burn 30 dB when you've got a connection that only needs 2? And so Anyway, that's getting into my wider argument of my thought process. But yeah, so I think at the end of the day, we have an opportunity here to redefine how much budget gets allocated to you guys as well. Now, obviously, there's crosstalk as well. Now, crosstalk's a huge issue, especially at these very high speeds. So I'm not saying I'm a genius around all of this. I've talked to the experts, and I know that crosstalk was a big deal on the OAM version 2, getting that up to 100 gig. And so your pin definitions are important there. Anyway, but that's a you know that. But so to your points, we absolutely have to dive into this. But I think we have an opportunity, and that's where this spec comes in. Is if we start to write the spec. And you guys, you know, and you, all of the connector guys go, there's no way we can do this in 224 gig with this signal integrity requirement. Then we can start to play with some of the parameters of what, or some of the assumptions, and say, well, if we change that assumption, does that make it possible? And if you guys jump around and say, yeah, that'd be easy if you did that, then we can explore that and negotiate with the other aspects of the channel to see if that's acceptable to everyone else in the room, rather than just say, sorry, Mr. Connector guys, you've got half a dB. This is your rule book. Get to work. Does that sound, does that allay your fears a little bit, Howard, or not?
Yeah. Am I on here? Yeah.
Yeah. Okay.
But I think I don't see why Jason and I can't be integral to this. And I think you need 2 sponsors anyway.
Oh, absolutely, absolutely. And no, so.
And I'm volunteering Jason.
No. The more. I mean, you know, if I had my way, I'd have every single connector company helping us drive this in the open world. You know.
Yeah.
But I realize only a few are necessarily going to pick up the baton, and it's you know, we're all volunteering right now, and you know, nobody's getting paid.
Well, if we start out with the MCIO style product, if you'll notice on your thing, it says Amphenol right on the photo you use.
It does, yes. Yeah, that's
So
where I got the 3D model.
it's not like Jason and I are the only ones around.
Yes. And certainly Z from Amphenol has been very he's been contributing. He's actually put engineering effort around some initial requests, like getting rid of the through hole features and all that sort of stuff.
Yeah.
So yeah, no, I mean, if we could get 3 companies collaborating on this and agreeing on some of these subtleties, and I like to be I like being the systems guy in the room saying, why can't we do this? And you say, because we've never done that. And I say, well, why have we never done it? Because the silicon guys won't let us. Well, sod the silicon guys. That's where I'm going to be coming at. Let's does this make sense from an overall channel, and where is the compromise? And if we make life easier for the interconnect guys, we're going to make life harder for somebody else. But how much harder versus how much easier? It needs to be a balanced compromise between each of the players. And as we're defining this from scratch, this is our opportunity. And with chiplets coming along, I think that redefines our opportunity quite alarmingly. And that's where I think the beauty of this opportunity is.
Yeah.
Just on this.
And I think when last fall in Santa Clara, Z talked, and I think if the 3 of us can collaborate on this, I can see this as being a good opportunity to, you know, make a difference. So as long as there's a significant business case for this, I don't think we'll have any trouble getting a response. And you saw when Alex presented the thermal bridge, there is buy-in from TE as well for.
Yeah, that's right. And that's where I think working together, we can maybe get there for the good of the industry, right? And well, I think that you guys as an industry, by the way, with your cross licensing, your RAND stuff, is actually a wonderful example of how you can make this work, and keep everybody in business, so to speak. Compared to the others, like it's minor nothing. And that's the thing with interconnect, by the way, is if you're trying to define an open standard, the interconnect is where everybody can plug together. So it's good that you guys have got to this arrangement in your industry. So that's where I quite like that approach.
It's not great for competition, though.
Yeah, I mean, obviously
The pricing guys don't like it.
No. But again, if you can make a little bit of a difference, or I know, I realize it's always tough. But if you can do a 224 gig passive cable and no one else can over 2 meters, then everyone's going to buy your cables and not theirs.
Yeah.
Okay, so that's that. Just the other slide was then once. So I showed so this is showing the passive copper, the active copper and active optical, and then I zoom in. I say, well, hang on, we can do the co-packaged optics, and this is 4 of the Avicenna light bundle chips. ICs just sat directly over the connector, and I said these can be chiplets, or they are chiplets already. But if this package was gone and we actually had chiplets on this substrate, we could actually maybe have very low picojoules per bit driving these chiplets here. And if you flip over and zoom in, we can see the little 4 light bundles there, which this is giving us. They're 1 terabit per second per transmit and receive. So this is 8 terabits per second, which is 8 terabytes per second. Which is a terabyte per second in total, and there's 8 connectors giving us 8 terabytes per second, which is HBM class bandwidth. And this is only Avicenna, so we do have Lightelligence on our call, and we have Adair Labs on our call from time to time. I'm not sure if they're going to do this approach, but I've asked all of them about light from the top of the board through a hole in the board to the bottom, so that you've got interconnectors on this dry side, where the wet side is all the water cooled side. So anyway, that's the idea. And this is the 4 fiber coupling ferrules that would be mounted inside the connector body, the main connector body for coupling these light ferrules to the. Now I'm not a mechanical guy, so it is a cartoon, but it's a 3D model cartoon. So I need everybody on the mechanical side and the optics side to say. The one thing about Avicenna is they say they need about 5 microns of alignment, and they said that's perfectly doable mechanically. You don't need active optical alignment when you're putting these things together. You can do it mechanically. So anyway, so that's the final step to the co-packaged implementation in a similar bodied connector. So, but actually, Howard, just to your other point, let me bring these slides back. Just to your other point, it's a big question: is there volume? And the problem we've got, which I'm sure you guys recognize, is we're so radical that that basically getting any of the big boys to say this is a good direction is really tough. But that was a reason, if you've not seen this presentation yet, or I did give a run through of early versions of it. It is recorded and it should go live shortly on the OCP website, and I'll send everybody a link when it does. But I essentially looked at the Blackwell implementation of NVIDIA's and said, look at everything that's going on. And clearly NVIDIA have now learnt that motherboards are useless now because they've gone to cables everywhere. They've got this massive power distribution with lots of power loss or opportunity for power loss in the copper losses. And signal integrity has gone from PCB to cables, and they've gone to this blind bake liquid cooling. So they're beginning to realize that what we realized 3 years ago, and we've been working in concept form, was we knew that the industry was going in this direction. And so, and I talked about building the frontier supercomputer with our modules. I talked about the power budgets, the way we need to bring memory much closer, energy-wise, large capacity memory, not just HBM capacity. And then I said we can go from a massive supercomputer to a telecom box on the edge, or these modules being used in the home. And so we would have one design for everything. And that would give you the volume that you were asking for, Howard, if we could get there. I'm sure there's a lot of industry, the telecom people would love to have their special NEBS compliant version so that they can charge a fortune for that compared to a regular server. But what we're saying is if we design this right, it could go from a supercomputer to the home. And then I go into the copper losses of the module. I go into our crazy thermal ideas of how to thermally manage this, and this is where we need somebody like you guys on the interconnect side, on the thermal side, to help us turn this into a reality. It's got complex three-nested control loops. I'm not sure how well the thermal industry is at control loops beyond very simple ones. But this is a nice complex control problem. So yeah, and this is why we need government money to get us started. I think that's the problem. Oops. Okay. So yeah, I guess that's where I've got to. So how do you think we can move forward then? I'm gonna basically turn that presentation into some words in the proposal document to sort of start that interconnect section of the document going, and then it's what do we do on the detail from you guys to make this proposal look compelling, and say what we're going to do to get it to a POC design and make some test cables. And how much is that going to cost? What funding do we need to do that? So that's what we need to get into the proposal.
Yeah, I think that the scope is a big scope there, and definitely it's difficult to find the kind of the solid solution for overall. But I think the other way is when we move on, maybe if necessary, then we can define for example, for different protocol area, and then we give kind of specific the consideration, maybe give them more clear the definition and for different application. Because for example, Ethernet and the PCIe, that's some area is a totally different world. Okay, so if we need to find a universal to fit both, and then it's tough. It takes more time. Okay, so if we see this kind of scenario, then at that moment we need to consider maybe two different versions. Okay, otherwise this one will be the gating to later this project to move forward. That's my thought.
Yeah, so I'd like to understand, just at the electrical and mechanical level, why can we not? I mean, the way I would think about it is you would design it to make sure it can work for 224 gig or 112, and then it's easy to support 32 in my mind. Now, obviously, we've got the impedance differences, which we all know about.
Yeah, that's before you mentioned they can do kind of switching something. Okay, there. But I have no idea whether definitely if this one is for high-end application, it doesn't matter about the cost. Okay, but if for example that the current server they count the every cent. Okay, there. Then will that add on that feature? Will that add some cost or add on the power or whatever? That's what I don't know. I don't know the answer.
Yeah. So I mean, if there's like I think that this needs to be a relatively rugged implementation. Now, obviously, we have the the manifold, the water-cooled manifold that surrounds. So that gives you a mechanical wall around the connector to stop people from just shearing the connector off. But if there is some, I don't know, some EMC aspects, like because technically it's like an external connector, whereas what we specified is an internal connector. So we might need some external attributes to say it needs some EMC, it needs to be more metal designed or something like that. I mean, I'm minded personally. I'm minded to go towards the more expensive end of making it a good, robust design all around. Because when you think of this, we have got rid of the entire 19-inch chassis and we've replaced it with the module in the middle. If we look at any implementations today of traditional implementations, you have this module in the middle, you have bypass cables going from these little internal connectors to the external ones like QSFPs, and we're getting rid of all of that. So it doesn't really, so we are saving so much money by doing away with the 19-inch rack to add more money into the design of the MCIO connector to make it a bit more cover the bases of ruggedization and external in multiple pluggability. People plug in and unplug in it a bit more often. Is not a bad thing in my mind. So in version 1, and then if we said version 1, the spec is we need to make this a fairly robust and not worry too much about the cost. I mean, I'm not saying the cost, obviously the cost is extremely important, and then we're going to be putting 8 of these on every single module, so they can't be $1,000 each connector for sure. There is a limit to it, but I would favor the more, let's make sure we cover all the bases from EMC, et cetera, on the design of it. And then as it ramps into production, if people believe they can strip a bit of cost out and it's not too detrimental, we're going in that direction of making cheaper variants of the same connector in the future. But at the get-go, I'd rather over design it a little bit for quality. That's
I think that my point is we still I don't want something block the road forward. Okay, so if the current this kind of the concept is okay, we move forward. But just when it happens that there are some kind of this roadblock there, and then at that moment we need to think about.
Well, that's what this is where devil's in the detail, right? So the more
details,
right. So the more progress we can make in maybe putting a spec together, so maybe a separate spec document. We've got a proposal, which we need to put to New Frontiers. But I think if we were working on a separate spec document like you guys already do on your interconnects together, I think if we start putting the meat into the spec, and then as we do that, you guys say, well, look, here's a major conflict between 224 gig and 32 gig PCIe. And what are we going to do to resolve it, or are we going to, or is it unresolvable? I think that's the conversations we need to have in this meeting going forward. And the more we can knock out and agree on how to solve before the proposal, the better. And it makes the proposal look that much more professional as well, because we've already thought about these things. Whereas, obviously that's the biggest criticism about this entire project is everybody looks at it and says, wow, it's really radical. It is innovative. It sounds very interesting, but it'll never work because everyone I speak to in the different disciplines tell me why it won't work. And that's when I start to get out of bed. When I'm told something won't work, I want to understand why. and I want to solve the problem with the experts to get around the why and is it solvable. So that's where I have most fun. That's why I'm here, really.
Okay. Yeah. Aidan, I think the current is the whole concept okay. But one thing currently we don't have the tray or enclosure to cover this one. So for each individual, that's the module. So how's the EMI? Any EMI concern here? Okay.
Yes, right. So that's a very good question, Jason. So I think that we have a little bit of a requirement on us to make the EMI around each interconnect as good as we possibly can. You know, so beyond a standard internal MCIO, I think that's one area where we definitely want to step up the game. But the other thing that is we haven't shown that so I've discussed EMC with I was trying to get IBM behind this, and so EMC was a big one on that. I think that what we'll have is once you've wired these modules up, we would have like an EMC like lid to go over the entire module.
Yeah.
And it may be a huge lid that would go over multiple modules, and you would, and so that would shield, but that would be a thermal lid as well, because you want all of the heat. You don't really want any of the heat to come out into the atmosphere. And I mean, the data center room is, if it's not cooled, it will rise to the temperature of the modules, which is 65 C, right? But we want 99% of the energy, the heat, to go out in the water. We don't want it to go into the atmosphere of the computer room. So there's a bunch of those. So I sort of see an EMC lid going over the whole module once it's fully populated. But equally, I think just through a good discipline, we would it would be good to design these connectors with a good EMC performance in the.
Yeah, but I don't think that we just consider the connector. I think that for each the module tile, okay, is that need some kind of the cover or shielding structure to cover that? I just consider the EMC, but also you also address the thermal, okay, heat dissipation. So that's so far from the old picture, I didn't see anything cover that. Okay, so I have no idea. Do you consider that or not? Because in all electrical device, there is a kind of EMI requirement. Although now we put into the data center, suppose they still have the kind of EMI requirement there, right? So for each tile, how to maintain the two kind of comply with the EMI requirement. That's I have no idea. Maybe
so that is again, I think that's an important requirement, and I'm thinking that we can do that with a shield over each of the modules. And so, you know, like a little enclosure that literally goes over the top of the media and all the interconnect. And that once the machine's been built, that gets applied over the top of it in some form. Into place.
Individual tile things we have the some cover or something can plug in to achieve that.
When you say individual tile, do you mean individual HPCM module?
Yeah, that's the tile, right? You call tile.
Yeah, right? Yeah. One brick in the wall, as we call it.
Yeah.
So yeah, each brick would have a lid. I mean, maybe you have a lid designed to go over multiple bricks, like 4 or 8. I've not really gone into that level. I'm not too worried about it, but yes.
So would it be similar to an SFP type of cage, but you know, from a material standpoint, not from size and shape, but
a QSFP type of cage?
Yeah. So
to be honest, I'm thinking it might be some sort of carbon loaded plastic or something like that, like some molded type lid, which is both thermally insulated and EMC And I guess that could be sprayed. I think some EMC enclosures are like sprayed plastic. You spray them with some light metal spray.
Like a vapor deposited or something, yeah.
Right. So again, I'm no material scientist, but yeah, I'm just thinking of some sort of like plastic material that you can dope with some sort of conductive metal. Or I mean, and there needs to be a balance, right? Because I want that thermal insulation as well as that EMC conductivity to stop the EMC from getting out.
Yeah.
Because you have to, because it's a water jacket as well as a shield. So an SFP
No,
would
it's
all,
no, it's not. No, it's not a worker. The water is contained in the design. So if I just flash up the design of the module again.
so an SFP cage design would be similar.
You got the EMC gasket around an QSFP cage.
Yeah.
Yeah.
Well, because it's pluggable.
Right. Yeah, that's because it's pluggable, right? So here's our module here, right? So here you go. So here's the module on the right.
Yeah.
We're talking about. So I would see literally like a top hat would go over the whole of this.
Yeah. That's why I say that if there's a kind of the shielding cable or something, after install that or something, we can plug in. But if there's some module with the cable, then we need to have the appropriate opening, right? So
Yeah. No, so the cable's going to launch out here, and then it's going to go up and down and left and right around the module. So the cable, there's going to be cable channels around. So wherever the top hat sort of sits, wherever if these cables need to come up halfway up these modules and then bend and, so whatever this makeup of these cables getting into their cable channels is, then the top hat would maybe sit above the cables and over the top of these modules. And there would be some, mounting, either clipping mounting of that to some of the more mechanical pieces of the module. But the water is running through this manifold and here. So the water it comes through a blind mate water connectors on the other side. So there's no water here. This is all of these devices are conductively cooled into this manifold. So
here I just kind of bring in this one. Okay, I think that we need to add this one consideration. Okay, like the EML, EMC. Okay, at least because getting to the application, then they need to see that,
Yeah, and by the way, I still agree though that we should design these MCIO connectors to have some sort of native EMC shielding, so we don't have much leakage out here, and so no, we're not entirely reliant on this top hat or we're not spraying AMC everywhere. So I think the design would be good to be EMC.
Yeah, because the current MCIO use the inside the enclosure. So,
right, exactly.
So that we need to still go through that kind of the leakage the test to make sure they can meet the external.
Yeah, that would be it. I mean, ideally, we would design this connector with some EMC shielding capabilities so you don't need this top hat as well.
Okay.
But the top hat would be like a bonus there for.
But the top part, because they still have the connector layer, the mating area still cause the leakage. Okay, so that's why definitely I agree that anyway. But if suppose in the future in the application we need to maybe if possible we do some test, make sure, because a lot of this connector currently use the inside of the enclosure. So
yeah, and I think that's where the POC comes in, right? Is we do our best in the POC, then we test it and we realize how good, bad, or indifferent the EMC is.
Okay. Yeah. Okay. That's I just bring in this give the actual topic. Yeah. Okay.
No, these are very good points. I mean, to be honest, this is exactly the level of conversation I'm wanting to get to. Where the expertise in your, like I say, I'm at the 50,000 foot level, so I say everything's easy.
We don't want to complicate, but just because from system viewpoint, finally we need to consider. Yeah. So yeah.
Yeah.
Okay.
Yeah. And I'm sure there's other aspects that we need to chew over as well, right? I mean, the mechanical rigidity. I've slightly designed this. This picture's a little bit out of date. I've put another wall down the side here so that we can make sure that the active cables do firmly mate nicely, and you're not bending the connector and cable when you've got the thermal mating. So we've got an extra wall down here, so that the topology connectors do get a good thermal mate and not get under mechanical stress when they're under thermal mating with the chassis. So
another here, I just from system viewpoint, because look at the each module, look at here current each row you have the 8 module, right? And is there any weight limitation there? Because now this one will put on the wall, right? But
no, so it's on the wall. See, these are so basically these 4 pins are
that is not a concern. But the concern is on top of that, the individual module they plug in, right?
oh, these media, you mean?
Yeah, that's media. Yeah.
Yeah,
and
yeah. So we
anything to hold that or battery.
Yeah, so that's again, so mechanically we probably need to think a little bit more about holding these in place.
Holding,
you know, is that enough? It's only about an inch or less. So will these modules fall out if they're so the latching of these modules, we need some mechanical latching of the modules, which means they don't fall out. And
because
that's not shown.
Yeah, like the memory card. Okay.
Yeah.
Somehow they need to experience the shock and vibration. And typically in the data center, they have the most strict the requirement there. So that's why I just add on the EMI.
No, we have talked about the latching requirement in the past, and so yes, that's something that, and I have asked the connector people to look at that on. So yeah, we need the interconnect of these because you can either plug cables into these connectors or media, and we do need some sort of latching mechanism which allows us to plug these in and release them. So yeah, that is certainly something that needs to be designed beyond this simple concept.
Okay. Yeah, okay. That's just put on topic. Okay, but the detail is later on.
Yeah, no, that's a very good one, and I think we need to address that certainly I mean, we've got the universal interconnects portion of the proposal. We have these other we do have these other connectors here. We need cables to be modified so they can work here, and even active cables that plug into these media slots. So you know, it's not just the topology. I mean, I just focused on the topology for the regional summit, but yeah, we do need you know, in our proposal we need to talk about this. So if we could get a specification going of how do we latch these modules, how do we support active cables, but I think if we do the topology one first, I think that's the most interesting one, and then what we've learned from the topology ones we can then translate over to here, and certainly the mechanical latching of everything, including the topology connectors, is a big topic. I mean, you know, I'm hoping that we can maybe even the design of this manifold might have some latching features built into it, but whether we have additional, you know, capability there, that would be good.
Okay. Yeah. All right.
But I think the module itself, it hangs on the wall. It blind mates the water and the power, but these pillars here will just keep it. You know, I'm imagining this could be up to 2 kilograms. You know, potentially, or at least 1 kilogram per module. But I you know, these don't have to be screwed in tightly into the wall, but they will mount into the wall, and these pillars will give you rigidity. So the main base of the module will be nicely mated to the wall in my mind. Again, I'm not a mechanical guy, so I may be wrong, but I feel as though it will be nicely mated. These media clearly, to your point, need latching to this module in a way that means, because these are going to be vertical, right? So these are going to be, this module is going to be on the wall vertically. So those media will have gravity pulling at them downwards, not pulling them in like they're shown at the moment. I see we're over time, actually, guys. Sorry about that. But good discussion.
Yeah.
All right. So yeah, I mean, if you guys can maybe think about yeah, how do we move forward with a specification or the proposal? Maybe we can, if you think, just go straight into the proposal and we can start talking about stuff. If you think that we need to do a separate specification for the universal interconnect, whatever way you would like to proceed is would be good. But the clock has started ticking now. We know for a fact that late June is when we get this RFP, and we'll have about 4 weeks to respond from late June. So the more work we can get done, the more polished it can be. And somebody else, Jeff, on one of the other calls, on the main call, was saying that there are a number of other grant applications that we could potentially go for. So once, putting the effort into this proposal for New Frontiers, if we don't get the funding, we've done the hard legwork and we can reshape it for other potential funding avenues as well.
Yeah. Okay. Yeah.
All right.
All right.
Well, thanks, guys.
Okay. Thanks, Alan.
Okay.
Cheers.
Thanks.
Bye.
Yeah. Okay. Bye.